All right, we're on 6.2 notes on multiplying polynomials. Use the distributive property to expand. So if we're distributing one term or monomial, we just distribute. If we have a binomial, we would do our FOIL method. But we're just jumping right in since we know how to distribute monomials. We know how to distribute binomials by a binomial. And we're going to do a binomial times a trinomial. Now, just to practice this, how would you name this? I said binomial, but what's the degree? We should know our degrees. It is a degree of 1, so it would be a linear binomial, and this one would be a quadratic trinomial. All right, fabulous. Now, there's a couple ways to do this. I'm just going to use a double distribution idea. I'm going to come through and distribute the w to all three terms, and that is going to be a w to the third, a positive 2w squared, and a positive w. Then I'm going to do the second distribution, which is distributing a negative 7 to all three terms. If you use the FOIL idea, and I didn't have this here, when you FOIL, you do the first and the outside, and then you come back and do the inner and the last. It's the idea that you're just doing distribution in an organized manner. So negative 7 times w squared is going to be a negative 7w squared. Negative 7 times 2, negative 14w. Negative 7 times 1, negative 7. So now I need to put them in order from highest power to lowest power. So that's that standard form. So out of all of these, the highest term is w to the third. Then I would look for w squared, and I would get a negative 5w squared. So when you multiply the bases, the variables, you add the powers. We add like terms, we keep the like term. Then I have my w to the first and a negative 14w to the first, so negative 13w, and then my constant is negative 7. That is my final answer. It should be in standard form with all like terms together. Okay, another method of multiplying this binomial and trinomial would be to use a box, so I'll show you that in another example. That's it. Now, just to practice, what would you name this? The highest degree is 3, so you said cubic polynomial, because 4 or more terms we call a polynomial. Is that required on this problem? No, but it's good practice. Okay, look at number 2. I have 2 things to do. So we are following the order of operations. As in, I'm going to multiply this first, I'm going to multiply or distribute this, and then I'm going to do subtraction. So I have to watch that. All right, so take a second and FOIL this or do your double distribution, however you want to look at it. So 2x times 4, 8x. Then I have a negative 18x squared. Then I have a positive 4, and then I have a minus 9x. I'm going to keep that in one big set of parentheses because that's my first chunk. And then I'm going to distribute this negative 2. So it's a negative 6x squared and a negative 22x. Now, if you want to group this in parentheses, that's fine, but it's like I'm adding this on. So do I need the parentheses? No. Here's the first chunk plus the second chunk. If I didn't distribute the negative sign, it would have been a negative 6x and a positive 22x, but it would need to be in parentheses to distribute the sign. Okay. I'm not multiplying this, I'm adding it. So put all your like terms together. Highest degree, x squared. So what do we get? Negative 24x squared, 8x, negative 9x, and a negative 22x. So that'd be negative 1x minus 22 should be negative 23x. And then I'm looking for my constants, which would be a plus 4. And that should be it. All right, are we agreeing with my answer? Any issues?
Yeah.
All right, what will we name it just for practice?
That's a quadratic trinomial.
Quadratic trinomial. All right, let's look at this next example and let's get a game plan together. So if I'm looking at this, I am not able to multiply everything at once. So I need you to determine what we want to do. Like, what are your ideas? Because it's all multiplication. When you say split it in half, what do you mean?
Like, after the 5 parentheses, and like break that apart.
Okay. So there's a couple ways you can do it. Now, the big idea is there's no addition or subtraction. So I would start at the beginning, and I'm sort of doing what you said without physically breaking it. I'm going to distribute that negative 3a to this. So a minus 15. I'm keeping that in parentheses because it's still times a minus 2, and it's still times a plus 8. Now, once I distribute the negative 3 to the first set, that distributes to everything else. So you're not taking the negative 3 to everything. That it's not addition and subtraction, that you're just distributing to the first set, and then that will distribute everywhere else. So a couple ways of doing this. We did the first piece. You could then go into foiling these two and keeping this to the side, or you could have sort of done what you were thinking, which would be do this, and then multiply it all at once. It's really up to you, but you can only multiply two things at once. All right, so a couple ways we can do it. I'm just going to keep going through. I'm going to put these two together and leave this at the end, but you could, again, have paired these up. So I'm going to FOIL this. Now it's going to be a negative 3a squared, and then a positive 6a, a negative 15a, and then a positive 30. That's staying in parentheses, and I have my a plus 8 in parentheses. Now, to me this makes sense. I want to clean it up first. If I go to do my next piece of multiplication, I have 4 things times 2 things. To me, it makes sense to clean up first. So when I multiply, I want to add any like terms and before I do my next step. So here is negative 3a, minus 9a plus 30. All right, double check that we agree. Still times a plus 8. Are we good? Oh, I missed my square. Okay, that would throw everything off, dropping a power like that, because then everything else would be off. All right, now am I good? Okay, so this problem is essentially the same as number 1. I have a binomial times a trinomial. So you could do what you want with this. I prefer to take the a times all 3 things and then the 8 because it makes my brain work a little better. You could distribute, everything needs to multiply. If I have 3 times 2, I should have 6 items when I'm done. Now, if you don't like that distribution, I'm going to show you this box method. You don't have to use it, but if I want to do a box, I would need a 2 by 3. I'm going to put the a and the 8 here, and then all these pieces go across, and we have to make sure we include the sign. You don't have to do the box, but for some people it helps them organize it. So do you see my pieces are all here, and then I just multiply. Negative 3a to the third. This would be a negative 9a squared, and this would be a 30a. Then I come down, negative 24a squared. This would be a negative 72a, and 3 times 8 is 24. Tack on a 0. So this helps me compartmentalize it, and then I need to get my final answer by going through and looking in the boxes for like terms. So negative 3a to the third. My a squareds go together to be negative 33a squared. Then this comes together to be negative 42a, and my constant of 240. So if you like the organization of the box method, use it. If you weren't using the box method to get that, you could just take the a and distribute it. You would have gotten all of the same numbers I did, but they just would have been lined up. Okay, so we understand that you can't do this all at once. You're going to do a little multiplication, clean it up, do the next set of multiplication, clean it up, and then multiply. All right, how are we doing number 4? So when you're looking at this problem, I cannot distribute the 3 over addition and subtraction. So what we did, in the last lesson, if this was in parentheses and I said 5d to the third, well, that's 5d times 5d times 5d. I can do that. I can't distribute a power over addition and subtraction. So I have to write this whole thing in that expanded form 3 times. Now, I cannot multiply all 3 at the same time. So I'm going to pair it up, and I'm going to multiply these two, and I'm not going to forget this. I'll bring it down. So you're just going to do your simple FOIL, 4c squared, outside. And guys, this is the one where if you can do the shortcut, do it. That'd be 10CD and another 10CD, so double the product. But I'm going to write it out for you. 10CD, inside is 10CD, and last is 25D squared. All right, there's that piece, and I'm going to bring down the 2c plus 5d. So it doesn't make sense to multiply this until I clean up like terms. Otherwise, I'm just doing more work, and that's more chance for me making a mistake. 20cd plus 25d squared, and then I still have my 2c plus 5d. Okay, do you want me to do just distribution, or do you want me to show that box again? Okay, however you want to multiply it. You could distribute the 2 to all the pieces and lay it out. I'm going to show that box method just in case you weren't sure of it. Again, you could make it 2 by 3 or 3 by 2. I'm just choosing it to do it this way. So here's my 2c and my 5d, and I'm putting this across the top. I don't typically use the box method when I'm doing it myself. I just do the distribution, but we have extra variables that might help some of you. 8c to the third. We're just multiplying like a times table. 40c squared d, 50cd squared. And I'm going to keep my c and d in that order. So 20dc squared, I'm going to write as c squared d, 100cd squared, and 125d to the third. Okay, so go through. You can only pair them up if they have the same variable with the same power. So I'm going to have an 8c to the third. And remember, we're basing, since we have c and d, we're basing the standard form on the c value. So there's my 8c to the third. And then I have c squared d's, so plus 60, c squared d. And then I have my cd squared, so a positive 150 cd squared. And then my last term is 125d to the third. So final answer, standard form. All right, so here now we have a trinomial times a trinomial. Agreed? A couple ways to do this. You could come in and distribute that 3m squared to all three things. Then come back, distribute the negative 4m to all three things, and then last distribute the 1 to everything. I'm fine with that. It would be a long line, and you could sort of stack them if you want. I'm going to go ahead and do the box method for this. You don't have to use the box method, but I'm going to show it. So whatever you do, it does need to be organized. I need a bigger box. I need 3 times 3. And on the outside, it doesn't matter which way you put them, as long as you have the signs. See how the signs build with that number. 2m squared, positive 5m, negative 9. Okay, go ahead and go through. Watch your powers. Remember, when you multiply, you add the powers. Watch your signs. So negative 8m to the third, whoops, positive 2m squared. So I'm just sort of going in order. If you were writing them out, we'd be getting the same numbers. All right, so I keep multiplying, watch my signs, positive 36m, and then my constant negative 9. Now, if they're in standard form and the powers sort of match up, least to greatest, and you're not, or greatest to least, and you're not missing, you'll notice that that sort of makes a diagonal. That doesn't always happen. So final answer, let's add up like terms. 6m to the fourth. Put these together, I should get a positive 7m to the third. Put these together, what, negative 45. M to the second, positive 41, M, and then my constant of minus 9. So you could use the box method on this. I'm going to show this if I would just distribute this. I'm focusing on the x squared, so I'm going to write it out. Negative x to the fourth. I'm going to distribute to the next piece, which would be a negative 9x to the third and a negative 4x squared. Then I'm going to come back and I'm going to distribute the 6x to everything. Now, you could keep going in one line. I'm going to stack it. When I take 6x times negative x to the second, I'm going to get a negative 6x to the third. So I just line up that like term. And then 6x times negative 9x would be negative 54x to the second. And then 6x times negative 4 would be negative 24x. Then I'm going to come back and I'm going to do that negative 7. So negative 7 times negative x squared would be a positive 7x squared. So I found my x squared, I lined it up. And a positive 63x. And last, a positive 28 with no x. Now, again, this only lines up that way if these powers match up. So I'm going to really be adding down vertically. That's my like term. Or if you just went straight across, you just go through and pull the like terms. This can be a negative 15x to the third. Negative 58. I think this should be a negative 51x squared. Am I good? Okay. And this adds up to positive 39. Yeah, I agree. Keep the x and my constant 28. Now, I didn't name these last two, but what would you name this one? Highest degree is 4. What was that? Quartic polynomial. And number 5 would have been a quartic polynomial too. No, quintic is a power of what? Quintic is a power of 5.
Yeah, I said it.
Oh, no, number 5.
Oh, okay.
Number 5 is also a quartic polynomial. I got the confusion. Okay, take a second. Let's read example 7. So we're talking about a trapezoid, and we have the height, and we have the basis, because remember, a trapezoid can look like this. The only thing you know about a trapezoid is you have a set of parallel bases. So the height is that 90 degree, that altitude. So there's your height, 2x plus 9, base 1, base 2, and then they gave us the formula for the area of a trapezoid. So I'm going to take that formula that they gave me, and I'm going to plug everything in. So area equals 1/2 the height. I'm definitely using parentheses. 2x plus 9 times, now we have base 1 plus base 2. So I'm going to put in here 3x minus 7 plus the other base is x plus 5. Okay, might have been a little overkill. I don't know that I needed both sets of parentheses, but if this was subtraction, we'd have to be careful. So do you see that I replaced everything with parentheses? That's all I did. Now, before I start multiplying, let's clean this up. I'm just going to leave that 1/2 there, but we could distribute it. And when I say clean it up, let's add like terms. The 3x and 1x is 4x. The negative 7 and 5 minus 2. And then it's your call. Do you want to distribute the half first and then FOIL? Or do you want to FOIL and then distribute the half? Okay, so there's two theories here. If you are going to forget this number or forget that it needs to multiply by everything, distribute the half first, but some of you are going to deal with this as a fraction or a decimal. I'm going to leave the 1/2 out here, and I'm going to FOIL first, but you don't have to do that. I just wanted to show you that sometimes it's easier to clean this up and then deal with your fraction at the end. So I'm going to FOIL this, 8x squared, and then we have our minus 4x, our positive 36x, and last, minus 18. And before I distribute that 1/2, I'm going to make my life easier by adding like terms. Oh, I lost my x. Watch that guy. And so my choice was to wait on the half because I didn't want to FOIL with a fraction or a decimal, even though we can do it. And now I'm distribute the half. But it's really important that that half goes to everything. So 4x squared plus 16x minus 9. This is the area, so it's a word problem. What would you lose credit on? It's a word problem. This is the area. Now, did they tell me what this was measured in? Nope. So I'm going to say this is the area is so many units squared or square units. But you should have a label on your answer.